and talk a little bit about computer-administered interviews and Wiki surveys. So in the past, a lot of the interviews that were done were either face-to-face with people talking or through the telephone with people talking. And I think increasingly we will have surveys administered by computers. This enables us to do change. So it enables us to do new kinds of interfaces and interactions with people. And it requires us to change. So we cannot take something that was designed for people talking to each other and just put that online and expect that to work as well. So my favorite example of this is when they first came out with TV, they had radio soap operas before they had TV, and they took a TV camera and they put it right in front of people doing a radio soap opera. And they said, now we have a TV soap opera. And you do not. You have a radio soap opera put on TV. And I think a lot of what we have is we have face-to-face surveys put onto the telephone and then put on online. So like, what would it look like if we thought about what a computer-administered survey would look like if we had never seen these other kinds of surveys? So I think it might look something like this. So this is kittenwar.com. So if you go to Kitten War, you will not hear anything else I say. Because you will see two pictures of really cute kittens. And then you will pick one that you like, and you will see more cute kittens. And before you know it, you spent 20 minutes clicking on kittens. So in addition to being a very fun way to spend your time, there's something a little bit deeper that's happening here. So if you click to see the winningest kittens, this is what you see. That's pretty cute, right? And if you click to see the losingest kittens, this is what you see. So it's very different. Let's go back here for a second. So this very simple and enjoyable information elicitation mechanism has detected what we consider to be a very noticeable social signal. The other thing that I love about Kitten War is that all of these pictures of kittens were uploaded by users. And this differs a lot from how we normally think about collecting survey data. So let's imagine that let's imagine I was a traditional survey researcher and I wanted to find the cutest kitten in the world. So what I might do is go to the library, I might look through some books, find pictures of kittens that I think are cute, put them on a survey, and have people respond to those kittens. And so there's two things that are pretty broken about that. So one is the cutest kitten pictures in the world are probably not in the library here. And then the second is that I've baked a lot of myself into that already. Like, what if I really like these kind of kittens? Like, there are people who choose to have these kind of kittens. That's great. So again, we don't want to bake ourselves so much into our instrument. Like, what if we had a way that we could discover new pictures of kittens that we never had seen before, and then simultaneously find ones that people find to be really cute? So another way of thinking about Kitten War is that it really solves a fundamental problem that exists in all kinds of social measurement. So on the one hand, we have techniques that are really good for quantification. This is surveys. But on the other hand, surveys are very close to new information. And so we have other techniques like interviews, focus groups, participant observations that are open to new information, but those are usually slow and expensive and hard to quantify. And so what if we could come up with an instrument that combines the quantifiability of a survey with the openness of an instrument? And that's what we were trying to do with this project. We call these Wiki Surveys. So just like Wikipedia evolves over time based on user input, imagine if you had a survey that evolved over time based on user input. So as we were creating these Wiki Surveys, and here this is a project I did with Karen Levy, who was a graduate student here at Princeton and is now a professor at Cornell. We thought, what are some general principles that Wiki Surveys should satisfy? So we didn't want to say, let's just take surveys that people did in 1950 and try to do something like that. We said, let's try to look around and see what are online information elicitation systems and information aggregation systems. What are, like Wikipedia, what are the properties that they have? And then what are the properties that surveys have? And how do we kind of combine them? And so we came up with 3 properties that we wanted, principles. The first is that we wanted these wiki surveys to be greedy. And let me explain what I mean by that. So usually as a sociologist, I'm supposed to not want people to be greedy. But in this case, it is very good for surveys. So if you look at a lot of web-based systems that are good for information aggregation, if you look at the amount of information contributed by each person, it's very, very unequal. So this is a ZIF plot, a rank order plot. So all the way on this side, on your left, you'll see the person that contributes the most. The y-axis is how much that person contributed. So this is like the person who's spending 80 hours a week on Wikipedia. There are people like that. I'm very grateful to them for their contribution. Then if we move to the right, we see lots of people who contribute a small amount. These are people who add a comma every month. And so one of the things that makes Wikipedia magical is that it can take all of this information from all of these people. Person wants to work 80 hours a week? Great. Person wants to add 1 comma a month? Great. We'll take all of that. And these are often sometimes called the fat head and the long tail. That differs fundamentally from the way that we collect data in the social sciences. So what we do is we say we only take a fixed amount of information from each person, typically. So if someone comes to you and says, I love your survey, I want to do it 100 times, you would laugh because you would say, why would anyone want to do our survey 100 times? Because it's so boring and such a bad user experience. So we are chopping off all of the fat head. And what if someone comes to you and says, I'll give you 2 minutes of my time? And we would say, nope, can't take that. Sorry, that's going to lead to non-response problems. So we chop off all of the long tail. And so we just take what's in the green and we lose all of what's in the gray. And so to put this into context of Wikipedia, if they accepted 10 and only 10 edits per person, they would lose about 95% of their edits. So there's a huge amount of information in the fat head and the long tail. And so with Wiki Surveys, we want to collect all of it. So then you may say, well, isn't that going to complicate your analysis? And the answer is yes. None of these principles give you free stuff. But the idea is that we would rather take on the complexity of the analysis rather than push that complexity onto users or not collect the information at all. So I think if you think about the way surveys are built, I think a lot of surveys are optimized for the researcher and they're not optimized for the participant. So we really wanted to also change that. Because once you think of the participant time as being the most valuable thing, we're willing to take on much more of the complexity ourselves rather than pushing that onto the participants. The second property that we thought they should have is they should be collaborative. And there we want the participants themselves to have a role in creating the questionnaire. This is how we can be open to new information. And finally, we want them to be adaptive. And again, this is part of treating the respondents' time as valuable. If we already know the answer, we want to ask them the most valuable question given everything that we know up to that moment. So most surveys, you form the questionnaire and then that's fixed, and then you collect 1,000 respondents. But by the time you've done 500 respondents, you know much more than you knew at the beginning. Traditional surveys are not good at making use of that. And that means we are wasting our respondents' time. So we said, these are the 3 properties that we want. And then we built, with a grant from Google, we built all our ideas. It's a free and open source platform where anyone can come and create their own wiki survey. So we believe that system building is a thing that happens much more in data science, where they actually build a tool that people can use. And we thought this is actually really something that we want to do. One, because it's cool to make this platform that everyone can use. And also, it's going to allow us to do the research that we need to do. If it wasn't for building this tool, we could not have done this project. So to give you an example, this is related to what Beth Novick was talking about last time. This is a project we did with Mayor Bloomberg's office in New York City. So they wanted ideas to make New York a greener and greater city. So they picked one question: which do you think is a better idea for creating a greener, greater New York? And then they seeded it with 25 ideas that came from their prior outreach. We put that into all our ideas and created a Wiki survey. And then they saw this interface. A visitor would choose between two randomly sampled ideas, and then they would choose again and again. And so it's basically like kitten war for ideas. Then also at any time, anyone can add their own idea, that big green button, which would then go into the queue to be voted on by others. In many of these applications, there's often a moderator to make sure that people don't upload things that are inappropriate. Also, at any time, anyone can view the results. So it's much more transparent than a normal survey. So normally, survey creators get information, and then they don't ever share that information back. So you'll notice, like, the way we do, like here, anyone at any time can view the results just in the same way that the survey creator can. So what is actually happening? What is the thing that we are estimating from this? So this is discussed in much more detail in the paper. I'm just going to give you a quick summary. So the data structure we have is votes that are nested within sessions. So a session is roughly like a person, but we don't know that these are one single person could create multiple sessions. Like if you visit today from your laptop and then you visit tomorrow from your mobile phone, we don't have any way of knowing that that's you both times. We could build extra infrastructure to do that, but right now we don't have that. So you see this, in the first session, the person saw item 4 versus item 1, and they picked item 1. That's the data structure we have. The thing that we want to estimate is we call the opinion matrix, which has one row for each person and one column for each idea. And it's the amount that person I likes idea K. So this is a huge matrix. Often we have thousands of sessions and hundreds of ideas. And most people don't actually ever see most of the ideas, because there's hundreds of ideas in these wiki surveys, and most people don't give hundreds of responses. So to take that data and estimate that matrix, there is a bunch of modeling assumptions. So basically, we make some assumptions about the distribution of opinions. We make some distribution assumptions about how people vote, given their opinions. And then we find the parameters that are most likely given the modeling assumptions that we've made and the data that we observe. Then, I should say there's a second step, which is that opinion matrix is not interpretable. It's too big. It's measured, it turns out it's measured on a probit scale, which is also not very understandable to people. So then we have a second step where we reduce that opinion matrix to a different summary statistic, which is the probability that this idea will beat a randomly chosen other idea for a randomly chosen person. We can simulate that out of this opinion matrix. And this is a data reduction step to produce something that is interpretable to a user of the tool and a stakeholder who's collecting the data. So this is, again, the question they had in some of the seed ideas. They recruited a bunch of people through Twitter, Facebook, and so on. This is not a random sample of people in New York, for sure. There's nothing that would prevent you from doing this with a random sample if you're willing to pay for that. So I want to emphasize, again, an online survey platform does not always mean not probability sample. In this case, it does, but these are really two separate things. Who you ask and how you ask are separate. So we had about 30,000 responses and 464 ideas uploaded. So what this graph shows you, this is like the cartoon that I showed you from Wikipedia, but this is real data now. So you see that the person who contributed the most contributed about 800 responses. And there are a large number of people who contributed a small number of responses. So we had talked about the fat head and the long tail. and designing to enable that. And here we see that's the kind of information that we were able to collect. In the inset graph is for the number of ideas uploaded. So there again, you see a fat head and a long tail. One person uploaded 50 ideas. A number of people uploaded more than 5. And so we're able to get this greediness in both of these things. So here are the results. So the x-axis here is the score. It goes from 0 to 100. And again, this is the probability that a randomly chosen idea will beat a randomly chosen other idea for a randomly chosen person. All of the ideas that are written in blue with the solid circles, those were uploaded by users. So 8 of the top 10 ideas were uploaded by users in this case. And this, to me, is like the most important graph because it shows the value of being open to these new things. These are things that get uploaded and score really high. Those are the kind of things we want to learn about. Now, you may wonder, what are these things that are so great that the mayor's office didn't know about? So we did interviews with the people at the mayor's office, as well as a number of other Wiki Survey creators, because this pattern we saw consistently across lots of Wiki surveys. Uploaded ideas scored better. So what are the kinds of uploaded ideas that score well? So one is, we found they fall into 2 categories. One is called alternative framings. So this is an example of an alternative framing. Keep NYC's drinking water clean by banning fracking in NYC's watershed. So this was uploaded by a user, and we said to the mayor's office, like, fracking, like, that's kind of a big deal. When they launched this, it was even a bigger deal. Like, don't you all know about fracking? And they're like, yeah, we know about fracking, but we wouldn't have expressed it that way. So we would just say, keep the water clean. We wouldn't say, keep the water clean by banning fracking. So in this case, this is able to come up with a way of expressing the idea that's more resonant with people. And I think that is an important lesson for people. As we construct surveys, we often use terms that are very meaningful to us, like social structure. That's like, a sociologist loves talking about that. And like, to us, like, I had a whole question on my general exam about what does social structure mean. And like, yeah, like, we can have a whole lunch table talking about what that means. And it's pretty clear that most of our respondents do not think it doesn't mean the same thing to them that it means to us. And so when we have surveys that are based on theoretical constructs that social scientists have debated for years and years and years, you can be pretty sure the respondents don't know those things. And so having the respondents express them in their own language can be very helpful. The second is actually novel information, things that they did not know about. So plug ships into electricity grids so they don't idle in port, reducing emissions equivalent to 12,000 cars per ship. So you may say, wow, that sounds pretty neat. And that's what the mayor's office said. Then you might say, well, is that actually true? And it turns out it's not quite true. But it's not quite false. So the number appears to be closer to 5,000 cars per ship rather than 12,000 cars per ship. And in the end, they thought, wow, this is a great idea. Like, and this idea ended up in, both of these ideas ended up in the plan. So it was valuable for them to have these alternative framings. It was valuable for them to have these novel information. And we thought more about why it was that these ideas that were uploaded kept scoring well. And then we kind of realized that it actually seems almost like something that has to happen. So I'm going to give you an argument now for, I will bet you a beer or a coffee or a tea or a water or a soda, we have lots of soda, leftover soda, that if you do a wiki survey, the ideas that are uploaded by users will score better than your ideas. And I will give you an argument for why that will be. So over here on your left, there are the seed ideas in rank order. So here the y-axis is the score. Higher scores are better. And on the right is the user contributed scores. And so there's 2 things you should see here. First, there are just many more user contributed scores, ideas. There's like 10 times as many. And the second is the user contributed scores have higher variance. So if your idea is that if we open this up to everyone in New York, we're going to get a lot of bad ideas, that is true. Like if you look at the user contribute, most of the worst ideas were contributed by users, right? But there's high variance in that source. And so if all we care about is extreme cases, then we want a high variance, high volume source of information. And so the challenge with, normally we think of variance as being a bad thing, something we want to avoid. But here, again, if we only care about the best thing, then we want to be accepting of variance. We want to be accepting of volume. We just need a mechanism that allows us to sort through all that. And that's provided here by the respondents. So the respondents are generating the ideas, and they're simultaneously helping you sort through them. And as long as the number of votes, the ratio of the number of votes to the number of ideas is the key thing for the scaling. But this can work really well as you can have lots and lots and lots of people and get high volume thing, because the same source that's generating that volume is also helping you sift and sort. Okay? So as a research project, though, this was something we wanted to do. A lot of research projects, you do them and they end and it's hard and you have to start something new. And like, you're just pushing this boulder up the hill. Like, I think a lot of research projects are like pushing a boulder up a hill. And then usually you get to the top and then you have to walk down to the bottom again and start pushing. And so what if we had something where research projects just got easier and easier instead of having to start the hardness again? So we had this idea that we would have participants. They would help us do research. That research would help us improve the website. The improved website would give us more users, which would lead to more research. And we could get this virtuous cycle where everything could continue to get better and better and better. This turned out to be super hard to do in practice. If people are interested in this kind of thing, I'd be happy to talk about it over one of the lunch tables. So we're currently hosting about 14,000 Wiki Surveys with about 23 million votes. They've been done by government organizations, nonprofits, and companies. And these questions I'm going to propose as lunch table topics about how we build a system like this and deploy a system. So to have a stable website running for 5 years that handles lots of traffic, there's a number of issues involved in that. And integrating it into the research process is also challenging. So with that, I'm going to stop for questions. Okay, we'll start with the live stream.
So we have a couple here. So how do you account for users who can write, sorry, it's still muted. No? Okay. My apologies. How do you account for users who can write scripts or bots to respond many times in a certain way to specific survey items in Wiki Surveys? So the case study here is the Bodie McBoatface situation.
Yes, absolutely. So we talked about thinking about in the first day, how would Lex Luthor use this, or what, like thinking about adversaries. So adversaries come up a lot here as well. So one of the things I want to say is if you have a specific idea that you want to vote for, you can't go and directly choose that idea. You have to wait until that idea comes up. So one of the mechanisms that makes it harder to game the system is that we choose what you vote on, you don't choose. That also is actually very good for statistical efficiency, that we can choose pairs that are most informative to us. So the very simplest attack of going and voting just for your favorite idea, that's a little bit harder. Now, I will say that we have detected certain kinds of attacks, and we have put defenses in place against some of those attacks. If I tell you what those attacks are and what those defenses are, those will be easier to circumvent in the future. So this is a real challenge in anyone working with a live system where there are adversaries. So if you will hear this, you often hear this about, let's say, Facebook or Twitter. They have fake accounts or they have other kinds of bad things happening on their platform, and they say, we're doing stuff to prevent it, but we can't tell you what we're doing because that will make it easier for the people who want to do bad things. So I am definitely sympathetic to that argument. I think In this case, the stakes are pretty low, and so for higher stakes, maybe we need a better mechanism for that. But I think it's impossible to build a fully manipulation-resistant system. And so the way we think about it is we just want to make the cost higher and higher for the adversary.
Okay, next from Aaron. I apologize if I didn't pronounce that correctly, and this has quite a few likes on it. If you allow individuals to view the preliminary results at all times, are you concerned that these results may influence participants' decisions?
That was actually the whole topic of my dissertation. So I thought about that a lot, and we'll learn about that on Saturday. But let me just clarify something about the way this is set up. So we've decoupled the process of voting from viewing the results. So you'll notice that when you are voting here, you don't see the scores. When you see the scores, you actually can't vote. It's too... So yeah, so you can go back, but again, let's say you go here and you say, wow, keep NYC's water clean by banning fracking in the watershed. I want to vote for that. You go back here, it's not here. You're going to have to keep voting many, many, many times until you can see that idea. So actually, by decoupling the voting and the viewing the results, and by having us choose what you vote on, not you, we think we minimize the concerns about that.
Okay, and then from Harry in Boston, he says, I see the United Nations on the list of clients. A lot of the issues that you're discussing are local. Can you give some examples of applications to international uses or policies?
Sure. So I'll talk briefly about the UN example. I'll talk, yeah, so I think in a lot of settings, this UN was, they were having an international meeting. They wanted everyone in the world to be able to participate. It's not possible for everyone in the world to come to New York and sit in this room, the room that they were in. So they said, we will have a wiki survey. Everyone in the world can participate. We will take the top 10 ideas, print them out, put them on a piece of paper that goes in front of every one of the delegates who is at this meeting. And that is a way that everyone in the world can have their ideas expressed in this setting through a process that is transparent and open. And so I think it's not as good as letting everyone be there in the room, but it is, a nice step towards more inclusivity through a process that's open and transparent. Let's go to some other questions. Yep.
So I can see how this is useful for idea generation and like voting on things. Mm-hmm. But I'm having a hard time seeing how we can use this to gauge attitudes, like for instance, racial attitudes, yep. Right? Or how do you feel about this particular group? Like I could just imagine that going very, I don't know, like it can, I just don't see it as easily applicable to this kind of platform. Yep. And those are lots of things that, psychologists, sociologists, yep. And other people are interested in.
Yep. So I agree with you. So when we started this project, I thought it would be much more easily useful for the kinds of opinion research that social scientists normally do. It turns out we often are not looking for the best thing. We often have ideas ahead of time about the things that we want responses about. And so in that case, a lot of the openness is not that helpful. I do think, I have seen it in research settings, it's sometimes used to find stimuli. So you want to find like words that you could use to put into a survey. You can use this for like a pilot testing kind of thing. I will say also part of the reason is that I've only talked about one summary measure of this opinion matrix. You could have other things where you would want to do clusters, like people who tend to think this about a certain group also tend to think that, where you don't have to pre-formulate what those ideas are. So I think part of it also is that there's a whole other part of this, which we haven't talked about, is how you actually estimate this opinion matrix. And it turns out that is complicated, or it was complicated to me when we did it. And so I think there hasn't been a lot of subsequent work of pulling other information out of that opinion matrix. And I think that has to do some with the computational complexity of those estimates.
As a follow-up to that, have you thought about, I guess, minimizing, and so like having forced choice with a finite amount?
Smaller set.
Yeah, a smaller set, and then using that to garner information about preferences and hierarchies?
Yeah, so that you can already do. So I think if you already know what the set of things you care about, there's like conjoint analysis and things like that. To me, the thing that was most exciting was, one, being able to work with a very large number of ideas, and two, where those ideas didn't have to come from you. So the other thing that we've noticed in this is that the space constraints that exist when you create a survey are actually much more intense than you realize. So for example, one of our first deployments was with the Princeton student government. And on a survey, they might get something like improve the dining hall. But with a Wiki survey, they could get things like bring back Taco Tuesdays, more French fries, better desserts. So on a regular survey, we wouldn't be able to ask every single one of those questions. It'd just be too much. And so by eliminating that space constraint, we have the possibility of getting much more granular information.
I find this really exciting. It's like a crowdsourced version of the ballot proposition system.
Mm-hmm.
Can you talk about what are like the next steps usually in the process? So like New York gets this list of ideas, and how do they go about implementing them? And do you participate in that process, or does the researcher participate?
So the next step is usually some decision maker takes these ideas and considers how to implement them and how much they cost and how to implement them all more or less together. I see that we're starting to need a break, so I'm going to take one more question. We will have a 5-minute break, and then we will have one more set of, we're going to have a 5-minute break after this question.
Do you optimize over the order of the choices, and also can you use the time they think about the choice?
Yeah, those are both great questions. The answer is not yet. So there are a number of things you could do. Imagine how to choose these pairs in ways that are statistically efficient. So one of the reasons we don't do this now is that I do think is important is that whatever we do here has to be very low latency. So as a social scientist, I was used to having as much time as I want to think about things and having as much time as I want to analyze. So if my analysis took a minute, that was fine, or if it took 10 seconds. So in a live system, though, the analysis has to be done instantly to choose what comes next. You can't have the system wait several seconds to choose. So we ran into some computational problems about how to do that. Those I know are solvable, for sure, but those turned out to be harder than we expected. So I guess the step back from this is thinking from moving from a data set to a data stream creates a lot of opportunities for these kind of adaptive choices, but it brings in a new set of constraints, particularly very, very low latency. So let's take a step back from the Wiki surveys. Let's take a 5-minute break. I will come back and I will do one more set of slides about combining surveys and big data, and then we will start the activity.